You're watching Statistics Made Simple and I'm Savita Wilson. Welcome back to my channel. Welcome back to Statistics Made Simple and I'm Savita Wilson. In this video, I'll be focusing on the important questions from the Vital Statistics chapter. So usually question number 36 will be a 10-mark question. So in the 10-mark question, it can be either STDR, which we have to calculate for two localities or two populations or two towns, or it can be GRR and NRR together, or it can be like two 5-mark questions based on vital statistics. But usually STDR as a 10 marker is a sure question. Compute GFR and TFR from the following data. The age groups in years from 15 to 19 till 45 to 49 are given along with the corresponding female population and number of live births. Now GFR is the general fertility rate and it is calculated for women in the childbearing age, that is 15 to 49 years. So in this problem, it is easy because they have considered only the age groups 15 to 49 years, but in certain problems they will give age groups prior to 15 to 19 and after 49 years also they may give age groups. In those cases you have to not consider the age groups before 15 to 19 and you shouldn't consider age groups after 45 to 49. You have to ignore them. So GFR should be calculated only for women in the childbearing age. So let us first write the formula for GFR. So GFR means general fertility rate, that is number of live births occurring to women in the childbearing age divided by average population of women in the childbearing age into 1000. So now let us first calculate the total female population and the total number of live births. So when you add up the total female population, you get 2,50,000, and when you add the number of live births, you get 21,105. Now let us do the substitution and calculate what is GFR. So therefore you get GFR is equal to 21,105 divided by 2,50,000 into 1000. So score of 3 zeros in the numerator and 3 zeros in the denominator, and on simplification you get GFR is equal to 84.42. Moving on to subdivision B. So next they have asked us to calculate TFR. TFR means total fertility rate, and the formula is TFR is equal to 5 times summation quinquennial ASFR. Quinquennial means the age group is of width 5. So if you observe all these age groups, they are of the inclusive type and they are of width 5. Where ASFR, that means age specific fertility rate, is calculated using the formula number of live births occurring to women in a specific age group divided by average population of women in a specific age group into 1000. So now let us go back to the table and then do the calculation for ASFR. So the first ASFR value is 1000 divided by 50,000 into 1000, so you will get 20. Similarly, 7,000 by 60,000 into 1000 is 116.67. So you can just take two places after the decimal after rounding off. The next one is 177.78. Then you have 125, then 4, and then 2.5. Here there is no ASFR. Next, find out the total of all these ASFR values, that is summation ASFR, which is equal to 445.95. So substituting in the TFR formula, we will get TFR is equal to 5 into 445.95. So therefore TFR is equal to 2229.75. Second question, from the following data, compute GRR. So they have given the age groups 15 to 19 up to 45 to 49, and the corresponding female population are given and the female births are given. In the previous problem for TFR, they had given us the female population and number of live births. For GRR and NRR, they will give us the female population and the female births. So GRR means the gross reproduction rate. So let us first write the formula for GRR. So consider GRR is equal to I times summation 15 to 49 WSFR, or you can also write this as 5 times summation WSFR. So because I, it stands for the width of the age groups, that is 5. Okay, so either you can write GRR is equal to I into summation 15 to 49 WSFR, or I feel that it is easier for most of the students to write the formula as 5 times summation WSFR. So WSFR means women specific fertility rate. So the formula for WSFR is FBX divided by FPX into 1000. So FBX means female births at a particular age group, and FPX means the female population in that age group into 1000. So now let us form the column WSFR in the table. So it is 320 divided by 8000 into 1000. So you get 40. Similarly, the next value is 60. Then we get 80, 100, 76, 40 and 8. Now find out the total. So summation WSFR is equal to 404. So let us substitute the totals in the formula. So we will get GRR is equal to 5 into 404. So therefore GRR is equal to 2020, and then usually we write female births per 1000 women. So GRR, if it is asked alone, it will come as a 5-mark question. If GRR and NRR are asked, it is a 10-mark question. Third question, from the following data, compute NRR. So the age group in years from 15 to 19 up to 45 to 49 are given. Then the corresponding female population, the female births are given, as well as the survival rates are given. So now the first step is to mark the female population as FPX. So F stands for female, P stands for population, and X stands for age. Then female births, mark it as FBX. So F is female, B is births, and X is the age group. Survival rate, you mark it as capital S. So first you write the formula for NRR. NRR means it is a net reproduction rate. So consider NRR is equal to I times summation 15 to 49 WSFR into S, where I is 5. So what is I? It is the width of the age group, so it is 5. So it is easier to remember the second formula, that is NRR is equal to 5 times summation WSFR into S. So this will carry 1 mark, and WSFR formula is FBX divided by FPX into 1000. So now let us calculate WSFR. So it is 1000 divided by 50,000 into 1000. So you will get 20. Similarly, 7,000 by 60,000 into 1000 is 116.67. Then you get 177.78. Next is 125. Then you have 100, 40 and 5. Now here, for this calculation, many of the students go wrong. What they do is they find out summation WSFR and then multiply by the total of S. So it's not like that. You have to form another column, WSFR into S. So it is 20 into 0.91, which is 18.2. Similarly, 116.67 into 0.9 is 105.003. Similarly, the next calculation is 158.2242. Then we get 110, 87, 34.4 and 4.25. So when we add up this column, we will get summation WSFR into S, which is 517.0772. So now let us substitute these totals in the NRR formula. So therefore we get NRR is equal to 5 into 517.0772, or NRR is equal to 2585.39. We write female births per 1000 women. Fourth question, for the following, compute STDRs for the two towns. Which town is healthier? The age groups are given as 0 to 20, 20 to 50, 50 to 70, 70 and above. Then locality A, population and deaths are given. Locality B, population and deaths are given. And the standard population is given. So this particular question is a sure 10-mark question. So it's really important that each one of you practice such type of problems so that you can score the 10 marks. So this is a very important and a sure 10-mark question. So let us first write locality A. The formula for STDR means standardized death rate. So STDR of A is summation PA divided by summation P. So this A is the ASDR, that is age specific death rate, which is number of deaths occurring in a specific age group in a year divided by average population in a specific age group in a year into 1000. Now the first step is to calculate capital P. So this STDR formula will carry 1 mark. Then ASDR formula will carry 1 mark. Then even summation P total will carry 1 mark. So when you add summation P, you will get 1 lakh. Now the next step is to find out ASDRs. So here we will write ASDRs, that is age specific death rates. We should find out for both the localities A and B. So A means ASDR for locality A and B means the ASDR for locality B. So the formula or the calculation is simple. It is the deaths by the population into 1000. So 128 divided by 8000 into 1000 is 16. Then you will get 5. Then 14, 63. Then similarly, ASDRs for locality B is 72 divided by 4000 into 1000. So you will get 18, then 6, 14 and 43. Next, we have to find out PA and PB. So this P stands for the standard population. So how do you calculate PA? It is 20,000 into 16. That is 3,20,000. Next it is 30,000 into 5, which is 1,50,000. Then 35,000 into 14 is 4,90,000. Then 15,000 into 63 is 9,45,000. Then find this total, that is summation PA, which is equal to 19 lakhs 5,000. So summation P total will carry 1 mark. Then ASDRs for both the localities will carry 1 mark each, so that is 2 marks. Similarly, the calculations of PA and PB will carry 2 marks. So till here it is 7 marks. So let's continue with PB calculation. So PB is 18 into 20,000 is 3,60,000. The next is 6 into 30,000 is 1,80,000. Then you have 4,90,000, 6,45,000. Then calculate summation PB. This is 16,75,000. So now let us go back and calculate STDR for both the localities. So therefore, STDR of A is equal to, it is 19,05,000 divided by 1 lakh. So 3 zeros in the numerator and 3 zeros in the denominator will get cancelled, and you will get STDR of A is equal to 19.05. So this will carry 1 mark. Now let's move on to locality B. So write the formula. Consider STDR of B is equal to summation PB divided by summation P, which is equal to 16,75,000 divided by 1 lakh. So cancel out 3 zeros in the numerator and 3 zeros in the denominator. So you will get STDR of B is equal to 16.75. So now among these two STDRs, you should find out whichever is least. So this STDR value will carry 1 mark. So it is 2 to 4, 5, 6, 7, 8 and 9. Now the last part is the conclusion. So since STDR of B is less than STDR of A, locality B is healthier. Thank you all for watching. So please do practice the problems on vital statistics, especially TFR, GRR, NRR, and most importantly, STDR. So practice makes you perfect, and I'm sure when you practice a lot of problems and get the answers, you will have a lot of confidence in yourselves. Also refer to the vital statistics video, or you can refer to the playlist on vital statistics, which has all the topics which are covered apart from the important questions. These also will be helpful for you to answer the 1 and 2 mark questions.